parallel lines have the same gradient. So my question is to determine whether the lines L1 and L2 are parallel. So L1 reads y plus 3x is equal to 5, and L2 reads 2y is equal to 8 take away 6x. Now in order to know if the gradients of these two lines are the same, first I'll have to arrange them in the form y is equal to mx plus c so I can see what the gradient is. So first I'll be using L1. So L1 will be y plus 3x is equal to 5. And I'll be transposing for y. So I can simply carry this positive 3x across the equal sign, and the sign in front of it will change from positive to negative. So I'll have y is equal to 5 take away 3x. Now remember, the form we want it in is y is equal to mx plus c. So what I'll do, I'll write the negative 3x first and then the positive 5. So I'll have y is equal to negative 3x plus 5. So now I have it in the form y is equal to mx plus c. So we can clearly see that negative 3 is our gradient and 5 is our y-intercept. So for L1, we'll have m is equal to negative 3 and our y-intercept is 5. So now we're going to be looking at L2, which will be 2y is equal to 8 take away 6x. So again, what we want to do is transpose for y. So I have this 2 being multiplied by the y. So I'll carry this 2 across and the operation will change from multiplication to division. So what I'll get is y is equal to 8 take away 6x divided by 2. So now that I have 8 take away 6x divided by 2, these two terms have a common denominator 2. So I'll write the 8 divided by 2 take away 6x divided by 2. So I'll have y is equal to 8 divided by 2 take away 6x divided by 2. So 8 divided by 2 is 4, and 6x divided by 2 will give you 3x. So I'll have y is equal to 4 take away 3x. And again, I want to arrange this in the form y equal mx plus c, so I'll write the negative 3x first. So I'll have y is equal to negative 3x, and now I'll write positive 4 behind it. So now that I have it in the form y is equal to mx plus c, I can clearly see that my gradient m is negative 3 and my y-intercept is positive 4. So for line 2, we'll have m is equal to negative 3 and my y-intercept is equal to 4. Now we can clearly see the gradient for L1 is negative 3 and the gradient for L2 is negative 3. So since L1 and L2 has the same gradient, these two lines are parallel. So I have, since L1 and L2 have the same gradient, the lines are parallel. So originally we had L1 in the form y plus 3x is equal to 5, and we transposed for y and got it in the form y is equal to negative 3x plus 5. So this is L1. And L2 we had it in the form 2y is equal to 8 take away 6x. We transposed for y and we got it in the form y is equal to negative 3x plus 4. So this is L2. So here I have the equations for L1 and L2 side by side. So you can clearly see they have the same gradient, but they have different y-intercepts. So now I'll sketch the graph of L1 and L2 to show that they are parallel. Now remember, gradient is equal to my change in y over my change in x. So a gradient of negative 3 will be negative 3 over 1. So if my gradient is equal to negative 3, my gradient is equal to negative 3 over 1. Where this negative 3 will be my change in y, and this 1 would be my change in x. So I just want to recall that for L1, the gradient is negative 3 and the y-intercept is 5. And for L2, the gradient is negative 3 and the y-intercept is 4. So here I have my Cartesian plane, and first I'll sketch L1, which has a gradient of negative 3 and y-intercept of positive 5. So first I'll plot the y-intercept, and the y-intercept for L1 is positive 5. Now I'll look at the gradient, which is negative 3. So that'll be negative 3 on the y and positive 1 on the x. So the change in y is negative 3. That means I'm going down 3. And the change in x is positive 1. That means I'm going to the right 1. So from positive 5, I'm going down 3. 1, 2, 3. So that's my change in y being negative 3. And then I'll go across the right 1. And that will be my change in x being positive 1. And now I'll draw a straight line to connect these 2 points. So here I'll have my line L1. Now I'll look to sketch L2, which is y is equal to negative 3x plus 4. So that means my gradient is negative 3 and my y-intercept is positive 4. So the first thing I'll do is plot the y-intercept. So I'll go to positive 4 and plot my y-intercept. Now my gradient is negative 3, which is negative 3 over 1. So my change in y would be negative 3. That means going 3 downwards from this positive 4. And my change in x is positive 1. That means going across to the right 1. So from positive 4, I'm going 3 downwards for my change in y. So that's 1, 2, 3. So that's my change in y being negative 3. And my change in x is positive 1. So I'm going across to the right 1. So now I'll draw a straight line connecting these 2 points, and that will be my line L2. So I draw my line connecting the 2 points. And this will be my line L2. So we can clearly see 2 lines with the same gradient would be parallel. Now perpendicular lines are lines that are at 90 degrees to each other. So the product of the gradients of perpendicular lines is equal to negative 1. So if 2 lines have gradients m1 and m2, and m1 times m2 is equal to negative 1, the 2 lines are perpendicular. So here I have, if the line L1 has a gradient of 2/3, we want to find the gradient of L2 if L1 and L2 are perpendicular. So I'll let M1 be the gradient of L1 and M2 be the gradient of L2. So if L1 and L2 are perpendicular, then M1 times M2 is equal to negative 1. And we know M1 is the gradient of L1, so M1 will be 2/3. So what I'll have is 2/3 times M2 is equal to negative 1. Now this is very simple to figure out. If I want to get negative 1, this number is positive, therefore this number will have to be negative to get a negative answer. And if I want 1, then I need something to cancel both the 3 and the 2. So I have 2/3 times negative 3 over 2. So you see this 3 will cancel this 3 and this 2 will cancel this 2. So we'll get 1. And a positive times a negative will give you a negative answer. So this is equal to negative 1. So therefore M2 is equal to negative 3 over 2. So therefore M2 is equal to negative 3 over 2. So if you ever want a gradient of a line that's perpendicular to another line, and you know the gradient of the other line, like in this case we know the gradient of one line was 2/3, and you want to find the gradient of a line that is perpendicular to that line, just invert the number. So I'll invert 2/3 and get 3 over 2, and you change the sign. So invert and change the sign. And that's how we get the negative 3 over 2. So here I have to determine whether the lines L1 and L2 are perpendicular. So L1 we have y is equal to 1/5 x, take away 2. So this is already in the form y equal mx plus c. So we know that 1/5 is the gradient and negative 2 is the y-intercept. Now L2 is such that 10x plus 2y is equal to 14. So this equation we'll have to transpose for y to get it in the form y is equal to mx plus c. Now before I do that, so for the line L1, we'll have the gradient is m1 and that will be equal to 1/5. And the y-intercept is equal to negative 2. So now we'll be looking at L2. So using L2, 10x plus 2y is equal to 14, and we're going to transpose for y. So the first thing I'll do is transfer this positive 10x across the equal sign, and the sign in front of it will change from positive to negative. So I'll have positive 2y is equal to 14, take away 10x. Next, I have this 2 being multiplied by y. So when I transfer this 2 across the equal sign, the operation will change from multiplication to division. So I'll have y is equal to 14 take away 10x divided by 2. So now these two terms will have a common denominator. So I can write y is equal to 14 divided by 2 take away 10x divided by 2. So y will be equal to, and 14 divided by 2 is 7, and 10x divided by 2 is 5x. So I'll have 7 take away 5x. Now let's rearrange this into the form y equal mx plus c. So I'll put y, I'll write the negative 5x first, and then the positive 7. Now for L2, we have the gradient m2 will be equal to negative 5, and our y-intercept is equal to positive 7. So now if these two lines are perpendicular, if you multiply m1 with m2, you're supposed to get negative 1. So m1 times m2 is equal to 1/5 times negative 5. So that'll just be 1/5 times negative 5 over 1. So obviously these two will cancel out. So 5 into 5, 1, and 5 into negative 5 is negative 1. So multiplying across, you get 1 times negative 1 is negative 1, and 1 times 1 is 1. So that's negative 1 over 1, which is just negative 1. So we have m1 times m2 is equal to negative 1. So we have, since m1 times m2 is equal to negative 1, the lines L1 and L2 are perpendicular. So I just want to recall that this is the equation of L1, and after we transpose for y with L2, this is the equation of L2. So now I'll sketch the graphs of L1 and L2 to demonstrate that they are perpendicular. Now for L1, we'll have the gradient m1 is equal to 1/5, we get that from here, and our y-intercept is equal to negative 2, we get that from here. So my change in y is positive 1, and my change in x is positive 5. So here I have my Cartesian plane. So the first thing I'll plot is my y-intercept, which is negative 2. So here I've plotted my y-intercept at negative 2 on the y-axis. So my change in y is positive 1, so that means 1 upwards from this negative 2. And my change in x is positive 5, that means 5 going across to the right. So I'll have 1 upwards for my change in y being positive 1, and I'll go across to the right 5 now. 1, 2, 3, 4, 5. And that's because my change in x was positive 5. So now I'll draw a straight line to connect these 2 points. So now I'll draw my straight line. And this will be my line L1. Now to look at the line L2. So for my line L2, my gradient m is negative 5, which is the same as negative 5 over 1. And my y-intercept is positive 7. So I wrote c is positive 7. So my change in y would be negative 5, and my change in x will be positive 1. So first I'll plot my y-intercept, which is positive 7. So I plotted my y-intercept as 7 on the y-axis. And now from the 7, my change in y is negative 5. That means going 5 downwards from the 7. And my change in x is positive 1, so I'll go 1 across. Now going negative 5 downwards for my change in y being negative 5. So 1, 2, 3, 4, 5. And now my change in x is positive 1. So I'll go 1 across to the right. So now I'll draw a straight line and connect these 2 points. And this will be my line L2. Now you can clearly see that L1 and L2 are at 90 degrees to each other. So L1 and L2 are perpendicular to each other.